Hi, in this video we're going to look at the idea of complex numbers or imaginary numbers. And here I've got a quote from a newspaper article in The Guardian where someone wrote in, Bob Jones from Aberdeen, Scotland, wrote in and said, "What are the use of imaginary numbers in the real world? Do they have a purpose, or is it just some mathematicians having fun?" Well, in answer to his last question there, I think it's actually a bit of both. Yes, they do have a purpose, a very real purpose, but yes, they were also mathematicians having a bit of fun. The picture that you got here, this profile, is of an Italian gentleman called Guimano Cardano. And he was a person that lived roughly in the time, or a little bit after the time, of Michelangelo. He started out, he wanted to be a doctor, but he couldn't get into medical school. And so he became a mathematician instead, and worked in a variety of different areas within maths. He did eventually become a doctor, but largely because of the fact that he had been a professor of mathematics in Italy. But his interest ranged to a wide variety of things, from biology to chemistry, astrology, philosophy, which are all sort of fairly standard things for intellectuals at that day. They didn't specialize in just one area. One of the other things that he did was he liked to gamble, because he got into financial problems later on in life, and he gambled to try and improve that situation. The more he gambled, the more he needed to find some sort of way around this. And he's one of the early people that investigated the whole notion of probability. He did work on the binomial theorem, and he was the first person in the Western world to really make systematic use of the negative numbers. So he took them on, whereas a lot of the academics at the time were a little bit skeptical about them. His big thing, though, was to do with trying to solve cubic and quadratic quartic equations. You know that we can solve quadratic equations using the general quadratic formula, but for mathematicians at that time, this is in the 1500s, they were trying to find a formula that would work for cubic functions as well. And he did a lot of work with that. And in the process of doing that, he came across the square roots of negative numbers. Now, the Egyptians had known all about the square root of negative numbers when they were back building the pyramids. They didn't like the idea that these numbers existed, but they just accepted it. For a long time afterwards, it was frowned upon. People didn't understand the notion of it. But Cardano is basically working within a system, and he said, well, the system appears to have these numbers. We're going to need to explore them. His work was taken up later by people like Descartes and Newton, Bombelli. Again, they didn't really like the notion of the square root of a negative number, but they accepted that it had to be there because the system seemed to have a space. The number system had a space for these things which they eventually called imaginary numbers. Euler then worked on the notion of imaginary numbers, and he was the person that introduced the notion of calling these imaginary numbers I, the square root of -1 as being I. And then later on, a French mathematician, he's also a bookkeeper, called Jean-Robert Argand, looked at ways in which we could represent complex numbers in a diagrammatic way. And we will be looking at these things called Argand diagrams a little bit later on. So that's a bit of the background into complex numbers. Where do we use them? Well, it's fairly highbrow. Engineers will use them. Physicists will use them. Physicists use it when they're looking at working with currents. Engineers will use them when they're looking at stresses on things like buildings and bridges, flows of liquids. Engineers developing speaker systems will use complex numbers. They've got uses within fuel cells, how the energy moves within those objects. When electricians work with alternating current, they need to have an understanding of complex numbers in order to balance the circuits. And yet, when Cardano was doing all of this, when Cardano was working with his imaginary numbers back in the 1500s, he was simply trying to make sense of a gap within the knowledge that existed within the number system at the time. He had no idea that they would be used in this sort of way at a later stage. So in that sense, it was simply mathematicians having a play. It was an academic pursuit that they were trying to understand, although they didn't necessarily think there were any practical applications for these. Those applications came with over time, and they're now used in all sorts of things. So electrical engineers will use them, quantum physicists will use them, sales analysts will use them, economists use them. What else they said on here? Mathematicians, physicists, statisticians, software developers will use them when they're working with algorithms. So on the OneNote, you will find a whole host of different places where complex numbers are going to be used. At this stage, you need to treat it as an academic pursuit. I can't say that I can explain it to you in ways that will make sense within the understanding that you have of the world around you at this stage. However, once you get to university, you'll find that you will use them a lot if you go down the scientific line. This was the article in The Guardian, and then a number of people sort of sent back replies to it, rather like a blog. Might also want to just have a look at those. I thought this one was quite interesting from Drennan in Oxford. He said, "Don't forget maths is an invention. If you like the rules of the game we play. Maths is not a science. It does not represent reality. It's a system that merely works." And that's where the whole idea of complex numbers started out. They needed to make sense of the system of numbers so that it would work. And I thought this one was quite interesting as well. David Vickery from Croydon in the UK say, imaginary numbers have been used extensively in the latest Conservative Party manifesto. I think a lot of politicians, whenever they're working for people's votes, will use imaginary numbers in all sorts of cases. So that's a bit of background to complex numbers and imaginary numbers. The next video, we're going to launch into how we go about working with these. Right, goodbye.